All right, welcome to Lab 8. Like in Lab 2, this lab is not Skynet based, and it's designed specifically to correct a common misconception. In Lab 2, we learned about the true nature of the seasons, why it's hotter in summer and colder in winter. In Lab 8, we'll learn about the true nature of the expansion of the universe. The common misconception is that in the beginning, space was pre-existing and vast and empty, except at a single point where all the matter and energy was accumulated. And then this point exploded, filling space. But that's the misconception. It's not the case, and it's never what the Big Bang Theory claimed. The confusion comes from the name, Big Bang, which makes you think of an explosion. The name was actually given to the theory by one of its detractors, Fred Hoyle, back in 1949, kind of poking fun at the theory, which was fine back then because there wasn't much evidence either way. But now the evidence is vast and overwhelming to the point that it probably shouldn't even be called a theory anymore, but a working model. And we'll scratch the surface of some of this evidence in this lab. So, if not an explosion, then what? According to the Big Bang Theory, matter and energy have always been spread uniformly across space, at least on the largest scales. On smaller scales, it clumps gravitationally. And instead of an explosion, space itself is expanding, carrying the matter and energy contained within it apart in the process. So, in this lab, we'll show that the expansion of the universe isn't about motion through space, but motion of space. We'll also show that our Milky Way galaxy is not at the center of this expansion, and indeed, that the universe has no measurable center. Lastly, we'll determine if the expansion is decelerating, constant, or accelerating as it goes. And this will touch on the topic of dark energy. Now, as of when I'm shooting this, we haven't finished this yet, but there will soon be a Lab 9, where you'll collect observations with Skynet and use these observations to help you measure Hubble's constant, the current rate of expansion of the universe. So if this lab is now done, you should go ahead and put in your observations for Lab 9 now, so you have them when you do Lab 9, and you'll find the instructions for doing this in Lab 9 Procedure Section A. Okay, that's it.